Good morning, students. This is the last topic in hydrocarbons chapter, that is benzene. The molecular formula for benzene is C6H6. As for formula, it is highly unsaturated compound. That means it contains a more number of double bonds and triple bonds. Even though presence of pi bonds in benzene, it readily undergoes substitution reactions rather than addition reactions due to its aromatic nature. Benzene is an aromatic compound because it follows 4n plus 2 pi rules. It contains conjugation double bonds. Each carbon undergoes sp2 hybridization so that it comes under aromatic nature. Whenever any compound comes under aromatic nature, that compounds undergo substitution reactions rather than addition reactions. Why we should mention this point here, addition reactions? Actually, in alkenes and alkynes, addition reactions takes place. If you see the reactions, in most of the reactions, only one product will be formed. So those are called addition reactions. In benzene also, double bonds and triple bonds are present. Double bonds are present, not triple bonds. So we think that addition reactions takes place, but instead of addition reactions, most of the reactions are what? Substitution reactions. That happens due to aromatic nature. In Greek, aroma means pleasant odor. That is means what? Pleasant odor. Next, aromatic compounds having more percentage of carbon than aliphatic compounds, so they burn with sooty flame. This is very important point. See, percentage of carbon in aromatic compounds is more than percentage of hydrogen. Okay, how to calculate percentage of carbon? See, benzene molecular formula C6H6. Here percentage of carbon is what? Percentage of carbon, how to calculate? The weight of carbon, total weight of 6 into each carbon weight, how much? 12 by this molecular weight, how much? 78 into 100. Whereas the percentage of hydrogen in this case is how much? 6 into 1 by 78 into 100. So clearly we can say that percentage of carbon is more than percentage of hydrogen in benzene. Not only in this case, in any aromatic compound, percentage of carbon is more. So what? So they burn with the sooty flame. That means when we apply heat to that compounds, they burns with the sooty flame. Next, aromatic compounds contains benzene ring. They are called benzenoid compounds. Examples. See, this is anthracene. If you observe this compound carefully, it contains 3 benzene rings. This is one compound, it contains 3 benzene rings. The name of that compound is what? Anthracene. Next, aromatic compounds do not contain benzene ring are called non-benzenoid compounds. See, this is also aromatic compound, but it does not contain benzene ring, so that this is called non-benzenoid compounds. What are benzenoid compounds? If aromatic compounds contains benzene ring, those are called benzenoid compounds. If they are not contains benzene ring, those are called non-benzenoid compounds. Next, the structure of benzene was proposed by Kekulé. According to Kekulé, benzene is cyclic structure. In benzene, each carbon undergoes sp2 hybridization and shape is planar. In benzene, each carbon having one unhybridized orbital, nothing but pure orbital. It involves formation of delocalized pi bonds. Why we should mention delocalized? See, if you observe the structure of benzene, see, this is the structure of benzene, this is also structure of benzene. In this case, here pi bond is present, but here pi bond is not present. Here pi bond is not there, but in this structure pi bond is there. Here pi bond is present, but here in this portion pi bond is not there. So what we have to understand from these two structures, in these two structures, position of atoms are not changed, only position of pi bonds are changed. This indicates that pi bond is present in all positions, that nothing but these pi bonds are not fixed, these are delocalized bonds. These are called what? Delocalized pi bonds. Next, those are formed by those those pi bonds are formed by unhybridized orbitals, because hybrid orbitals cannot form pi bonds, they can form only sigma bonds. Next, benzene having 18 hybridized orbitals and 12 unhybridized orbitals. Correct. Because the structure of benzene is like this: CH double bond, CH single bond, CH double bond, CH single bond, CH double bond, CH single bond, CH. If you observe this structure, each carbon atom forms double bond. So how many carbons are there? 6. Each carbon undergoes which hybridization? sp2. sp2 means how many hybrid orbitals? 3. 3 into how many carbons? 6. 3 6 18 hybrid orbitals. Next, number of pi bonds are how many? Number of pi bonds how many? Number of hydrogens how many? 6. 1 2 3 4 5 6 plus 2 into number of pi bonds how many? 3. Total 12. These are pure orbitals. 18 hybrid orbitals, 12 pure orbitals present in benzene. Next, one more important point. These two are what? Resonance structures, because they in those structures position of atoms are not changed, one position of pi bonds are changed. From these two structures we can get one more structure. This is called resonance hybrid. The structure of resonance hybrid is formed by combination of two structures. That means if you combine these two structures, then we get this structure, that is called resonance hybrid. These two structures are called what? Resonance structures. Those are also called canonical structures. Next, the resonance energy, that means what? The energy of the benzene is 36 kilocalories per mole, or 150.48 kilojoules per mole. That is the resonance energy. Next, the CC bond length in benzene is intermediate between alkenes and alkenes, that is 1.39 angstroms or 139 picometers. In case of alkenes, 1.42 angstroms. In case of alkynes, 1.34 angstroms. But this value lies between alkenes and alkenes. That is the meaning of that point. Next, preparation methods of benzene. This is important. We can make benzene from sodium benzoate. See, when COH present on benzene ring, that is called benzoic acid. If that H is replaced by sodium, that is called sodium benzoate. When the sodium benzoate reacts with soda lime, what is soda lime? The mixture of NaOH and CO is called soda lime. This type of reaction came in alkanes, where CH3CO Na reacts with NaOH and CO, then we got which one? CH4. Like that here also, this Na2CO3 will be removed. Finally, we got which one, students? Benzene. Next, reduction of phenol. Phenol means what, students? If OH present on benzene ring, that is called phenol. When this phenol undergoes reduction in the presence of zinc, then this zinc removes this oxygen from phenol, and finally it removes as ZnO, which will be left, benzene will be left. This process is also called distillation. Next, one more method, that is what? From ethylene, that is also called polymerization. This reaction already came in properties of ethylene. When 3 molecules of ethylene passes through red hot iron tube or copper tube, then we get benzene. This reaction is also called what, students? Polymerization. What is the meaning of polymerization? What is the polymerization? Formation of larger molecules from smaller molecules is called what, students? Polymerization. So that is these are the preparation methods of what? These are the preparation methods of benzene. First reaction is what? Reaction with sodium benzoate with soda lime. That is also called decarboxylation. Whenever you get decarboxylation reaction in exams, you can write this reaction, or you can write that reaction also. Which reaction? The reaction which came in alkanes. That also you can write. Then you get full marks. So from sodium benzoate, from phenol, from ethylene, we can make benzene. These are the preparation methods of benzene. In next video, I will discuss the chemical properties of benzene.